In this video, we're going to go through the most difficult exam question you're expected to know how to deal with differentiation from first principles. So this is the equation that's given to you in an exam. Once you have the function that you want to differentiate, we call that f of x. It's already called f of x here, so we don't need to do that. But to get f of x plus h, what that means is wherever there's x, you want to substitute into it x plus h. So that would be root of x plus h. Putting all of that into this expression here, we have the limit as h tends to 0. I'll explain what's meant by that, by the way. Of f of x plus h, which is root x plus h. Take away f of x, which is root x. All divided by h. So where we go from there is we actually use the difference of two squares. That's what makes this different from all other questions. Because right now, h is inside of the square root, so we can't really deal with it until it's out of the square root. How we do that is you multiply by everything on the numerator, but you swap the minus sign for a plus sign. So it becomes root of x plus h plus root x. And then let's also do that to the denominator. Root of x plus h plus root x. So when you do the difference of two squares, the middle term cancels out. So straight away we know that root x plus h plus root x multiplied by root x plus h. The squares will cancel out, leaving you with just x plus h. Like we said, the middle term cancels out, so we just need to do minus root x times root x, which just gives you minus x. All of that divided by h multiplied by all of this. Root of x plus h plus root x. Okay, now x minus x cancels out, so then we're left with the limit as h tends to 0. In the numerator, we're just left with h. And in the denominator, we're left with h multiplied by everything that we had before. Root of x plus h plus root x. Now the h on top and bottom cancels out, leaving you with 1. So what we have is the limit as h tends to 0 of 1 over root x plus h plus root x. Okay, let's talk a little bit from here. So limit as h tends to 0, what does that mean? That means as h gets smaller and smaller and smaller, what happens to this whole expression? Well, you can say that as h tends to 0, x plus h, it just tends closer and closer to x. Because if you think about it, if you're adding a smaller and smaller number onto x, it's just going to get closer and closer to x. So what we can say is that we can get rid of the limit as h tends to 0 sign, and we can say that this all just tends to x. So I'm going to use a arrow now instead of an equal sign because it's tending to 1 over, like I said, this whole term here now will just become root of x because x plus h is tending towards x plus root x. Like terms, we can add them together, so it becomes 1 over 2 root x. You can write this out as 1 over 2x to the half, or even a half x to the minus a half. And that's the final answer to this question. If you actually differentiated root x, which is x to the half, you'd also get a half x to the minus a half. Hopefully that will make sense. It's quite a difficult example, which is why I wanted to highlight it, but be sure to let me know if you have any questions about it.